Just look there. So we are going to discuss in this class just a reason of logarithms. Complete formulas discussion and the concepts logics discussion happens in this class from logarithms. Okay. See logarithms. For suppose if you have an exponent, basically exponents are very familiar with us. Just like a power n is equals to b. If this is an exponent, okay, and this exponent can be expressed in two different ways. Here if you look, a power n is equals to b, where that b is the subject and we are writing b as a power n, that in the sense multiplication of a for n times is b. And if you make from this, if you make a as the subject, I will write it like this: a is equals to b power 1 by n. If you send n that side, it becomes like b power 1 by n. It is just a notation, it is not a definition or anything. It is just a notation, okay? Or you may call it as a separate definition. If a power n is equals to b, then we write a is equals to b power 1 by n. Here if you look, a is the subject. That in the sense we are expressing a in terms of b and n. On the other hand, if you make n as the subject, then you need to send this a that side. Now in that case, we will write that n is equals to logarithm of b to the base a. We read it like logarithm of b to the base a, and we write it like this: n is equals to log b base a. And here if you look, that n is the subject and we are expressing n in terms of b and a. So at the end, this is exponent, and those exponents can be rewrite in two different ways. One way is a is equals to b power 1 by n, and the other way is n is equals to log b base a. This a is equals to b power 1 by n leads to the concept of nth roots, okay, and further which leads to surds also. And this n is equals to logarithm of b base a is just nothing but the concept of logarithms. At the end, this a power n is equals to b can be expressed like n is equals to log b base a. If you look there, a power n is equals to b if and only if n is equals to logarithm of b base a. So if you have this exponent, you can write it in terms of logarithms. If you have this logarithm, then there is a possibility to rewrite it in terms of exponent. And among these two, this a power n is equals to b is mentioned as exponential form, whereas this n is equals to logarithm of b base a is mentioned as logarithmic form. And while converting from exponents to logarithms, you need, since logarithms are just nothing but the restatement of that exponent, rewriting another notation for the exponents. So in logarithms, if you are going to establish any new formulas, new laws, new logics, always you need to get the support from the exponents. So see, to make it as well defined discussion, that in the sense logarithm of b base a is a well defined thing, you need to concentrate on the exponents. Here if you look there, a power n is equals to b, there you may get certain confusions if the base is negative value as well as if the base is 1. So to avoid those confusions, you need to restrict that a must be, what is that, this base of this exponent, as well as here this base, that base must be greater than 0 and not equals to 1. Why we are making those restrictions? Because without those restrictions, sometimes you may get a certain different confusions and some contradictions. To avoid all those contradictions, you need to restrict the base a should be positive as well as that base cannot be 1. Okay, so this conversion happens if the base a is greater than 0 or not equals to 1. And another thing is, once think about that, this base is positive value and n is any value, okay? There are no restrictions on the n, you may take any real number in the place of n. And once again, you just think that this base is positive and power n is any real value. Positive number to the power a real number always gives us a positive, it won't give us negative. So since this base is positive and power any real, that result b is also positive. So make sure that this b is greater than 0, that is another restriction, okay? See, while defining this n is equals to logarithm of b base a, these are the restrictions from the exponent a power n is equals to b, and now you need to apply these restrictions for this n is equals to log b base a. So if you have a logarithm n is equals to log b base a, there you need to mention, you need to be sure that this a should be greater than 0 or not equals to 1, whereas that b is greater than 0, okay? And the next thing is direct observations from the logarithms. What are the direct observations? See, once again look there, a power n is equals to b and n is equals to log b base a. Yeah, this n is equals to log b base a. You just take this log b base a and replace here in the place of n. Just an observation, right? A power n is log b base a, right? Log b base a here. So you will get that a power log b base a is equals to b. Just by rewriting that n is equals to log b base a in this statement, you will get that a power log b base a is equals to b. And in the same way, n is equals to log b base a, but here b is equals to a power n. If you replace a power n, b as a power n in this second thing, so you will get that n is equals to logarithm of b, you just write it like a power n is equals to logarithm of a power n base a. These are the two basic laws from the definition itself. Okay? Yeah. And for suppose using these laws you can answer many questions. For suppose they may ask you if you face the situation like this, 17 to the power of logarithm of 19 to the base 17, what is its value? And if you observe, this is of the format like a power log b base a. Here these two terms should be same. It looks like the same. So your answer is that 19. There ends the task. So to answer these type of questions, we will go with the a power log b base a is equals to b. Okay, right? That's the definition and two observations from the definition. And again, see, every law of logarithm, every logic of the logarithm, just we develop from the concept of exponents. And now if you look there, it is very familiar that a to the power 0 is equals to 1. See, a to the power 0 is equals to 1. It happens only if that a is not equals to 0. That's the restriction again here. Okay. Yeah. So anything to the power 0 is equals to 1. And if you look there, if you convert it into the logarithmic form, so if you send this a this side, it will become that log 1 to the base a is equals to 0. So always you need to memorize that logarithm of 1 to the base a is 0. So if you generalize it, logarithm of 1 to the base 2019 is 0. Okay. And in the other thing, a power 1 is equals to a. So if you rewrite in terms of logarithms, send this a that side, it becomes in the logarithm of a to the base a is 1. Logarithm of a number to the same base is always 1. So for suppose if I have that logarithm of 17.8 base 17.8 and its value is 1. So these are the two basic laws. One thing is logarithm of 1 to the any base is 0 and the other thing is logarithm of any number to the same base is 1. And we have these two basic laws of logarithm just from the concepts of exponents. And one more idea is logarithm of 1 to the base 1 is not defined. Okay, logarithm of 1 to the base any number is 0, but that any number can't be 1. Why? Because here there is a restriction for a can't be 1. So logarithm of 1 base 1 is actually an indeterminate form and an undefined term in the logarithms. Okay, so this is the basic definition and these are the basic laws, and then I am going to give you the standard laws of the logarithms. Okay, so everything is just a revision. We are revising the laws of logarithms, definition of logarithms, as well as I am going to mention you some logics of the logarithms. Okay. Third point, where I am going to give you the standard laws. Yeah. Standard laws of the logarithms. All these standard laws again we can just develop from the concept of exponents itself. So we are very familiar with this law of exponent. What is that? Yeah, a power m plus n is equals to a power m into a power n. I think you are all familiar with this law. Then if you using this law, we will develop a law of logarithm, and that is logarithm of ab to the base x is equals to logarithm of a base x plus logarithm of b base x. You just make sure here that logarithm of the product is equals to the sum of the logarithms. Once again I am repeating, logarithm of the product AB is equals to the sum of the logarithm. And there is a chance to extend this law. Logarithm of ABC to the base x is again is equals to the logarithm of a base x plus logarithm of b base x plus logarithm of c base x for 3 terms. So this law, see, we have a chance to apply this law for any number of terms. So always logarithm of the sum of certain terms is equals to the sum of the logarithms. For example, if I have this thing, see, logarithm of sum 2 into 3 into 17 base 5. Okay, or you may take some other terms again. So I will rewrite it like this: logarithm of 2 base 5 plus logarithm of 3 base 5 plus logarithm of 17 base 5. And if you extend this law of logarithm, see for example if you have logarithm of a to the power n base x. Logarithm of a to the power n base x is simply nothing but logarithm of a into and so on into a to the base x. So now if you look there, logarithm of the product of a's, how many a's are there here? N a's. So if you apply that law, we have a chance to extend it. See, to express it as a sum of logarithms, logarithm of a base x plus logarithm of a base x plus and so on plus logarithm of a base x. And at the end, how many log a base x's will be there here? See n, so n times the logarithm of a base x. So logarithm of a power n base x is equals to n times the log a base x, and it is, see from the definition itself we already stated this particular statement, and now here again we proved it using this what this is standard law of the logarithm. At the end we have here different standard laws, and I will mention all those standard laws. So the first standard law of the logarithm is simply what? Logarithm of the product is equals to sum of the logarithms. Okay, the first one. Or you just neglect the numbers. Logarithm of something like, if you say a b c d base x is equals to logarithm of a base x plus logarithm of b base x plus logarithm of c base x plus logarithm of d base x. Logarithm of the product is equals to sum of the logarithms. And the other thing is logarithm of a power n base x is equals to n times the logarithm of a base x. And if you extend, see if you have, see we have another law of exponent, and that is a power m minus n, or you may take it as something like x power m minus n is equals to x power m divided by x power n. Using this law of exponent, we will develop another law of logarithm, and that law is that simply logarithm of a by b base x is equals to logarithm of a base x minus logarithm of b base x. Just have a look. Logarithm of the division is equals to the difference of the logarithms. Logarithm of the product is equals to the sum of the logarithms. Okay. Using all these things, there is a possibility to write different problems. Okay. To simplify different values. For suppose if I have something I need to say, see, you may take something. Logarithm of 289 base 17. What is its simplified value? Then use this law of logarithm. Logarithm of 289 base 17 is nothing but logarithm of 17 square base 17. And logarithm of that 17 square base 17 is simply, as per this law, you need to write 2 out. Okay. Then it can be expressed like this: 2 logarithm of 17 base 17. And since it is 2 logarithm of 17 base 17, and this log 17 base 17 is 1, and at the end its answer is 2. So using the laws of logarithms, we can directly find the values of logarithms in such a manner. Is it clear? Right. Okay. Yeah. And for suppose, how to use this logarithm of a by b base x is equals to log a base x minus log b base x. For suppose if I have a problem in such a manner, yeah, something like logarithm of 120 base 30 minus logarithm of 4 base 30. For suppose if I have a problem like this, I need to find the value of logarithm of 120 base 30 minus logarithm of 4 base 30. So directly we have no chance, and then use this law of logarithm. Log a base x minus log b base x can be written as log a by b base x. Once you just think about the bases, the base should be same here, same 30, no problem. And then this is equals to logarithm of this division, 120 divided by 4 base 30. Logarithm of 120 divided by 4 is again 30. Logarithm of 30 base 30, and that is equals to 1. Just I am mentioning here some basic examples, because some of you may get confused related to the logarithms, and that's why I am giving you the basic examples. Using these basic examples as well as these standard laws, we can easily solve many problems. Okay. So coming to the standard laws, one law is the logarithm of product is equals to sum of the logarithms, and the second law is logarithm of a power n base x is equals to n log a base x, and the third law is logarithm of a by b base x is equals to log a base x minus log b base x. Don't get confused. Okay. Here a b c d the product, and there the sum of the logarithms, and here the division, and here the difference. Okay, don't get confused about all these things. And then we can extend, we can develop different laws of logarithms from the concepts of exponents again. Okay, now for suppose one more law is logarithm of a base b is equals to 1 divided by logarithm of b base a. Just have a look about this. Logarithm of a base b is equals to, yeah, before that we have another thing. Logarithm of a base b for suppose is equals to logarithm of a base some x into logarithm of x base b. Just have a look. See, it usually helps us to change the base of the logarithm. Here logarithm of a base b, whereas there if you look there, logarithm of a base x into logarithm of x base b. Okay? And in the next step, what can I do? If you see, this x may be any number, that x may be any number. Okay, we have a chance to rewrite in different manners. Logarithm of a base b is equals to logarithm of a base x into logarithm of x base b. For suppose if you send this log x base b this side, then it becomes like this. Logarithm of a base x is equals to logarithm of a base b divided by logarithm of x base b. Just have a look. You need to pay your attention on the, see, the pattern, how the formula is there. Logarithm of a base x is equals to logarithm of a base b divided by the logarithm of x base b. Here it is a and x. Whereas coming to the right side, the base, same base you need to take for the numerator as well as for the denominator. Okay. And this is true for every value of x, a, b and b. And now if you take again x is equals to some b, what will happen? Okay, no problem. Yeah, x is equals to what my idea is, yeah, another law of logarithm. From there we can develop it like this. Logarithm of a base b is equals to 1 by logarithm of b base a, with the same idea. Logarithm of a base x into logarithm of x base b is equals to logarithm of a base b. If you use it in different manner, you will get that logarithm of a base b is equals to 1 by logarithm of b base a. And one more thing is, here we have that logarithm of a power n base x is equals to n log a base x. In the same manner, if you have logarithm of a base x power n, see, look there, here a power n base x, and there I am writing that logarithm of a base x power n. In this case, we can express it like this: 1 by n times the logarithm of a base x. All these are the different laws of logarithms, and still by using the combination of all these laws, there is a chance to develop many other laws also. Just have a look, go for a screenshot, and then I will continue from there. See, just look there, the other laws of logarithms. Okay, logarithm of a power n base x power m is equals to this n comes to the numerator and this m comes to the denominator, and there is a chance to write like this n by m into log a base x. This is one problem, one law, standard law. And the other standard law is a power log b base c is equals to b power log a base c. So these two terms gets interchanged here. So this is another law. So using this we can solve some questions like this. So 3 power logarithm of 4 base 5 divided by 4 power logarithm of 3 base 5. What is its value? Just if you look there, the c is same in both sides, and this a and b gets interchanged. We have a chance to prove it using again exponents. Okay, then with this standard law, 3 power log 4 base 5 by 4 power log 3 base 5, this 5 is same and 3 and 4 gets interchanged, and its value is 1. So if you memorize all these standard laws, easily we can solve many questions. And now I gave you here one problem related to the standard laws of logarithm. Logarithm of a base b is equals to t, then we need to find that logarithm of a power m divided by b power n base b power p. So the first thing is, this is the division, so you just express it like a difference. Logarithm of a power m base b power p minus logarithm of b power n base b power p. So logarithm of the division is just simply the difference of the logarithm. And the next step, this is logarithm of a power m base b power p. Then by this law of logarithm, you just write this m in the numerator, p in the denominator. It becomes like m by p logarithm of a base b, minus here again you just write this n in the numerator and this p in the denominator. It becomes like n by p logarithm of b base b. And now in the next step, this logarithm of a base b is given as t, whereas this logarithm of b base b is 1. So this is equals to m by p times of t minus n by p times of 1. And further, this is your answer for this logarithm of a power m divided by b power n base b power p. So this is one simple problem related to the standard laws of the logarithm. Just have a look. Just look there. The first point is the definition, second point is the basic laws, and third point is the standard laws, and the fourth point is related to the natural logarithms and the common logarithms. See, there are different logarithms with different bases. So in particularly, logarithm of a number with base e are mentioned as natural logarithms, and with base 10 are mentioned as common logarithms. See, commonly we will use the decimal system of numbers. Since we are using decimal system of numbers, there is an importance for the 10 and the powers of 10. So logarithms with base 10 are mentioned as common logarithms, and logarithms with base e are mentioned as natural logarithms. And here e, okay, if you don't know about that e is usually Euler's constant, and its value is approximately approximately 2.7 something. Okay, you just leave about that value at first. See, with base e it is natural logarithm, with base 10 it is the common logarithm. And for suppose if I have a logarithm with base e, and how to convert it into the logarithm with base 10. So as per the standard law of logarithm, this logarithm of n to the base e can be written as logarithm of n base 10 into logarithm of 10 base e. Here both these terms are same, so these two are equivalent. And now in the next step, this is logarithm of n to the base e, and this is logarithm of n to the base 10, and this logarithm of 10 to the base e. 10 is a number, e is also a number, and this value from the logarithmic table you get it as 2.03 approximately. So this logarithm of n to the base e is equals to 2.03 times the logarithm of n to the base 10. So this relation helps to convert a logarithm from the natural logarithms to the common logarithms. And usually you will face you will use this equation and this conversion in different types, in different situations of chemistry as well as in physics also. Okay, just look there. This is related to the natural logarithms and the common logarithms. Just have a look. The fifth one, logarithmic inequalities or the comparison of logarithms. So how can we compare logarithms? How can we see? First of all, we need to think about, to establish the logarithmic inequalities, whether that logarithmic function is either increasing or decreasing. That's what you need to discuss. And that discussion is again possible just with the help of exponents only. Here I am mentioning only what I am mentioning just the statements, just as a formula. So complete discussion you just do with the concept of exponents. Okay, now what I am going to give you is, if x less than y, okay, if x less than y, there are two numbers such that x is less than y, and now if I wish to apply or logarithm with base a on both sides, logarithm of x to the base a, logarithm of y to the base a. So which inequality sign I will get between these two? So usually this is very clear. If x is equals to y, then you just simply write that logarithm of x to the base a is equals to logarithm of y to the base a. So if you have x is equals to y, you just use this one. Or if you have this logarithmic equation, simply you just cancel logarithm with base a and you will write that x is equals to y. But whereas coming to the situation of inequalities, if x less than y, then if and only if logarithm of x to the base a and logarithm of y to the base a, which inequality sign we need to use in between those two. So to decide that inequality sign which we need to write in between these two, you need to think about the concept of exponents again. Okay, so if this base a, okay, from the concept of exponents, now I am mentioning that the inequality sign between those two, if this base a is in between 0 and 1, then you need to use opposite sign. Whereas if this base a is greater than 1, then you need to use the same sign. So if x less than y, if and only if logarithm of x to the base a is less than logarithm of y to the base a, it happens only if the base a should be greater than 1. You need to memorize that base, if it is greater than 1, then it is true. Whereas in the other case, if x is greater than y, so if x is greater than y, then in that case, or not, no, see, if x is less than y again, if x is less than y, then logarithm of x base a and logarithm of y base a. So here you will use opposite sign, greater than. So here it is less than and you are using opposite sign. And this is possible if 0 less than a less than 1. That in the sense 0 less than base value less than 1. So while applying logarithms on both sides of an inequality, you need to think about the base. If that base is more than 1, then you just directly use the same symbol. Or if that base is in between 0 and 1, then you need to use the opposite symbol. Okay? In other words, here if you look there, if x is less than y, then logarithm of x base a is again less than logarithm of y base a. That in the sense, if x is smaller, log x is again smaller. That in the sense, in this case, if base is greater than 1, logarithmic expression is mentioned as increasing expression, because x is lesser, log x is lesser. Y is greater, log y is greater. So if you changes this x, y, so x, y, z like that, if you increase, logarithmic values also will increase in such a manner, log x, log y, log z. So that's why we call that logarithmic expression or the function is increasing in the first case. Whereas in the second case, if the base is in between 0 and 1, since x is less than y, still log x is greater than y. So for the smaller value of x, the logarithm value is more. For the larger value of x, the logarithm value is smaller. That in the sense you need to use opposite sign. So that's why here in this case we mentioned that logarithmic function or the expression is the decreasing one. Using this basic idea of the logarithm, it is easy to sketch the graph of logarithms, as well as it is easy to compare two given logarithms again. Okay, so this is about the logarithmic inequalities. Just have a look. See, you just think about that. See, for example, if I have logarithm of some n to the base x or n to the base some 10, and no problem, logarithm of some a to the base b. See, this logarithm of a to the base b is a numerical value. For sure, it is a value, okay? And I will express this value in terms of its integral part plus fractional part, where this I is the integer and f is the fraction, where this I is integer and f is in between 0 and 1, that in the sense, and the value of f must be in between 0 and 1. So like that we need to express. If you express logarithm of a base b as a sum of integral part and the fractional part, we usually call as integral part, and this integral part of the logarithm is mentioned as characteristic of the logarithm. Whereas this fractional part, which is in between 0 and 1, this fractional part of the logarithm is mentioned as mantissa of logarithm. Okay, so for any logarithm, its value can be expressed as a sum of integral part and the fractional part. That integral part is mentioned as the characteristic of the logarithm, and that fractional part is mentioned as the mantissa of logarithm. And using this characteristic and mantissa, integral part and fractional part, okay, basically using integral part, usually characteristic of the logarithm, we can decide the number of digits of this a, as well as if you know about that a, and we will decide the position of that logarithm, location of the logarithmic value, where it is located and everything. Okay, and this is just simply about the characteristic and mantissa. There are different problems related to this characteristic and mantissa, and